we are going to continue looking at division properties of exponents. So let's simplify each of these problems. So we have our quotient being raised to the negative fourth power. So we have 2 to the negative fourth power times by m to the fifth, but to the power of negative 4, so we're going to multiply. M squared to another power of negative 4, so we're multiplying. So we have 2 to the negative fourth, m to the negative 20 power, m to the negative 8. So from here, we have like bases of m, and we have a negative 20 minus a negative 8, which equals a negative 12. So we have 2 to the negative fourth, m to the negative 12. So to rewrite this, we have positive exponents. This goes in the denominator. Same with m to the 12th. Last step, 2 to the fourth is 16, and we have m to the 12th power. Here we are multiplying, so we have 2 times 3, which equals 6. Like bases, so a to the 7th times a squared, we add our exponents. 7 plus 2 is 9, divided by 6, a to the third power. Well, 6 divided by 6 is 1. We have a to the 9th divided by a to the third, so since we're dividing, we're taking our exponents and subtracting. So our final answer is a to the 6th power. Here we have our quotient raised to another power, so we have n to the fourth raised to the negative fourth power, so we multiply. N to the negative fourth power divided by n to the negative second power raised to the negative fourth, so we multiply. So n to the 4 to the negative fourth is really n to the negative 16th, n to the negative fourth divided by n to the positive 8. So here we are multiplying like bases. So we can add our exponents. Negative 16 plus a negative 4 is a negative 20 divided by n to the 8th. So lastly, we like bases, we are dividing, so we take our exponents and subtract. So n to the negative 28th power. Rewrite, so we have a positive exponent. Alright, we're raising our quotient to a negative 2, so we have 2 to the negative second power, x raised to the negative second, y to the 6th being raised to the negative second, so we multiply. X to the third raised to the negative second, so we multiply that one as well, and y to the negative second. So this turns into 2 to the negative second power times by x to the negative second. 6 times negative 2 is a negative 12. 3 times negative 2 is a negative 6. So we have like common bases of x. So negative 2 minus a negative 6 equals 4. So we have 2 to the negative second power times by x to the fourth. Our like bases of y, we have negative 12 minus a negative 2, which equals a negative 10. So then we can rewrite this using positive exponents. So x to the fourth stays in our numerator. 2 to the negative 2 goes into the denominator. X to the 10th. So lastly, 2 squared is 4, so we have x to the fourth divided by 4 times x to the 10th power. Oh, that's a y. Here we are multiplying. There's nothing we can combine in the numerator or in the denominator, so here we are dividing like bases. So we take 3 minus a negative 2, which is 5. So we have a to the 5th power. For our b's, we have exponent of 2 minus 5, which is a negative 3. C, we have negative 4 minus a negative 9, which equals a positive 5. So c to the 5th. So rewrite this using positive exponents. We have a to the 5th times by c to the 5th divided by b to the 3rd power. Once again, we are multiplying, so 5 times 6 is 30. We have no more like basis. We have a to the second times by b to the third divided by 2 times 25 is 50. Like bases are not, so we have a to the third times by b to the negative second. Well, 30 divided by 50 reduces down to 3/5. A squared divided by a to the third, so we take our 2, subtract 3, we get a -1. B, we have 3 minus -2, which is 5. So we have b to the 5th power. So rewriting this using positive exponents, we have 3 times b to the 5th power divided by 5 times a. Let's look at our last example problem for the day. So we need to rewrite each expression using only one exponent. While looking here, I know we have m squared, m to the 4th, and we have a 4, which can be rewritten as 2 squared, because 2 times 2 is 4. 169, if I find one number I can multiply twice, is 13. So 13 times 13, or 13 squared, equals 169. M to the 4th can be rewritten as m to the 2nd times by 2. So if I take a look, all my exponents are 2. So if I rewrite this as 2 to the mth power, or sorry, 2 times m, divided by 13 times m squared, because we have it 2 times, all raised to the 2nd power.